Hi, everyone. First, thank you for having me part of your own DevFest. It's a great pleasure to be here with you. And before I start on navigation component, I'd like to ask you some questions. So if you can answer in the chat, you would help me in the talk. Okay, so who of you has already read some documentation on navigation components or seen a talk on navigation components? You can type one. Okay. Okay, so Qais. Anyone else? Okay, great. Awesome. So who of you actually uses navigation component on a daily basis? Omar, you use it? Yes. Awesome. And everyone else, you never heard of navigation components? Okay, Flutter. Awesome, great. So I can tell you that this talk is made for you. So I will try to have a brief introduction on navigation components so we can dive a little bit deeper on how we can use navigation components in different types of projects. Actually, in one typical type. Okay, I'll share my screen. Okay, to start, a little bit about myself. My name is Layale Matta. I'm from Lebanon, and I am part of, I have joined Neo Technologies just recently as an Android engineer. Other than that, I have 4+ years of experience in Android development, and I'm also part of GDG Coast Lebanon and Women Tech Makers. So what is Jetpack? Jetpack is the trend today. So if we want to have a very, very short definition, Jetpack is Android's next generation of components and tools. If we have a little longer definition, it would be Jetpack is a suite of libraries, tools, and guidance to help developers write high-quality apps easier. And I'd like to highlight on easier. How does it make it easier? These components actually will help you follow best practices, free you from writing boilerplate code, and simplify complex tasks. So 3 in 1. That's a really good start. So if we look at Jetpack's libraries, the components are separated into 4 different categories. A navigation component is part of the architecture. So we have foundation, behavior, UI, and architecture. And I have to mention that all of these components work on older versions of the platform. So they are all backward compatible, which is a plus for this. So when we talk about navigation components and navigation in general, moving from one screen to another, this is absolutely a fundamental part of Android development. And historically, we used to do this using intents and fragment transactions, right? And it was really easy enough for example, a button click or a navigation from an activity to another one. But what if we wanted to implement something slightly more complex? For example, we have a button navigation view, and we not only want to move from one tab to another, but we want to make sure that the right tab is highlighted. And we want to handle the backstack properly. So the user won't be confused when clicking on the back button. So in all of these use cases, this is where navigation component will shine. So in definition, navigation component is a collection of libraries and plugins that are used to simplify Android navigation. So if you need to dig more, this is the link for the documentation. Of course, I will share the slides with you at the end of the talk. And this is the link to the code lab. It will actually guide you through how to implement navigation component yourself. Now, let's dig more into what can we actually use from this component. Let's dig into the API. So beyond that, it simplifies the setup of the Android navigation. This component actually handles the backstack, fragment transactions, argument passing, navigation-based animations, and deep linking. But most importantly, it gathers all of this navigation information in one visualized location inside of your application. And this is the navigation graph that we will check in a bit. The navigation component works out of the box using fragments and activities. And of course, you can extend the library to work with any of your own custom views. Now, in this talk, we will be using examples using single activity, swapping up multiple fragments, okay? So if you are wondering why you might consider using single activity, I really recommend this talk. I have added the link to it in the notes. So one way to look at a navigation component is that it has three major parts that are working in harmony together. And they are the navigation graph, the nav host fragment, and the nav controller. The navigation graph is actually a new resource type. It's an XML file where you have all the navigation information of your application. And this information can actually be visualized in a navigation editor inside of Android Studio. So it looks like this. It's a graphical editor that helps you create your own navigation graph. So all of these screens that you are seeing, they are called destinations. And destinations, and they mean that there are some places that you can actually navigate to. In this example, we are using only fragments. And these arrows that you can see, they are actions, and they represent the different paths that a user can actually get into and to move from one fragment to another. And all of this information is actually generated in one navigation graph XML file. Next, we have the nav host fragment. It's actually a simple fragment that you add inside of your layout. It acts as a window where you swipe in and out fragments that are actually destination inside your own navigation graph. And to see it in the code, you can, for example, have your activity, and inside of it you add this fragment container view, which has the Android name of nav host fragment. And the final part of our puzzle is the nav controller. Every nav host fragment should have a nav controller. And it's actually the nav controller that instructs the navigation to happen. It makes it occur. So if we have, for example, this code, this means that we are using the nav controller to navigate from fragment 1 to fragment 2. In this example, we have used the action ID, but we can actually use as well the destination ID. So it can work with both action IDs or destination IDs to go from fragment 1 to fragment 2. Of course, you can add to this arguments that you need to pass. For example, as we used to pass bundles, you can add this using the save args library, but we won't go into this right now. So a basic example, the basic recipe to build your own navigation components. First, you add the library dependency, then you create a navigation graph. You add the nav host fragment inside your layout. You get the nav controller, and then you navigate. We won't forget about the first part. This is the code to add your dependency. And as you can see, we have an additional library, the navigation UI. This is in Java. And of course, if you're using Kotlin, we have the KTX extensions. And this navigation UI library, it actually helps you to bind your navigation component to option menus that comes on the top of your action bars, button navigation views, the navigation drawer that comes from the left, as well as action bars and toolbars. So everything is taken care of with navigation components. Let's dig a little bit deeper into the nav graph, navigation graph. So as we said, the navigation graph declares all the reachable destinations. And as a constraint, we have that every nav graph should have one and only one start destination. And by this, I mean the home fragment, the first fragment that actually shows when we start the activity. Of course, it can contain actions and nested graphs. We have the destination. The destination is a node of this graph. It's a screen to be displayed, and as we have seen, by default, it's a fragment. And we have actions. Actions are nested into the destinations node. Of course, they can be part of the top level, the root level of the graph, and they will be called global action, but we won't get into this in this talk. Of course, it has to have a target destination because it will tell us where to navigate to. It will navigate us somewhere. It can define animations. It can have a back behavior. But the most interesting thing about it is that it can share the same IDs. We know that layouts in Android, every layout has to have a different ID so we can differentiate between them. But actions are different. They can actually share the same ID, and it could be very beneficial to us. We will check this in a bit. So now that we have some basics, we can actually tackle some real problems. Let me tell you about a problem I had to solve, and it's actually a real use case scenario where I learned to use and use navigation components. So we had this application that has multiple activities, okay? And each activity was an entry to a very big feature, okay? The logic was very complex. It had very complex flows. It was kind of a lot of forms that are integrated into each other, conditional navigations, etc. So we had to find a solution in order to have a clean code and maintainable code. So we set some rules to be followed in order to maintain this code. So what we decided was that first, we need to centralize the logic in a single place, of course, per feature, or it can be on the app level. And of course, the inputs and outputs will be handled through the view model because we decided to follow Google's standards and use the MVVM architectural pattern. And most importantly, only one element uses the nav controller, one element. So what we created was a pattern that we called the flow manager. You can call it anything you want. We just called it flow manager. The role of this flow manager was to convert any navigation event into a navigation destination. And another role for it is to check for any destination changes that needs to be made and to let the view model know about them and eventually apply these changes on the screen, depending on which screen we are on. So if we want to visualize it a little bit, we have our activity. It has its own view model, the flow manager, and the nav controller. As we said, the activity view model will send the navigation event to the flow manager. The flow manager, as I said, will convert this navigation event into a navigation action, of course, by using the nav controller to be able to navigate. And on the other hand, the nav controller will check for the changes to be made, will send them to the flow manager, and the flow manager will update the view state and the view model. Now that we have a pattern that actually works, let's see if the flow, when it gets wider and tricky, if this pattern actually helps us. So let's start easy. We will start with the linear flows. So in the linear flows, we have different fragments, as you can see, that we can actually go from one to the other. So if we look at the file, XML file, the navigation graph of this layout, we can see that we have here 3 fragments, right? In the first 2 fragments, each fragment has an action. And each action is actually targeting the second fragment. And also, these actions have different IDs. So the first action is info to phone number, and the second one is phone number to verify SMS token. So in order to write this, if you remember in our flow manager, we want to write this. So in our flow manager, the flow manager will receive different navigation events, and then it will compute and decide what good action it needs to execute. So here in the navigation function, we are checking which current destination we have. And by current destination, I mean the actual fragment screen that is displayed right now. If the screen is the info, we will execute the info to phone number action. If this screen is the phone number, we will execute the phone number to verify SMS token action. So this is easy, and this can be actually done. But what if we wanted to make it more efficient, right? More efficient code in our flow manager. What can we do? These actions that actually have different IDs, we can actually use the same ID. Here we called it action next, which actually tells literally what we are doing. We are going from one fragment to the next one. And imagine how much simpler our code in the flow manager now can be. It's one single line of code. So every time we are going to execute the next action. Why? Because we are linear. There is only one way to be executed, one direction. That's great. So we added this as a rule to be followed. So when a destination contains one single action, we will always use a generic ID which we called here action next. Now, what if we have non-linear flows? You can actually see this by looking at the second screen. It has two target destinations. So how do we handle this? If we look at the navigation graph, we can actually see that the first fragment has actually two actions. So here, we can't use the same ID because obviously we won't be able to differentiate between the two actions. So what can we do? We will actually kind of do the same. We will still look for the current destination, the current screen that is displayed. If it is the phone number, which is the second screen, we will call this simple function, get phone number action. That will actually compute and decide what action will be executed next. Otherwise, we will execute the action next. Why? Because all the other flows are linear flows, as we saw earlier. And the simple get phone number action will be very simple. It will actually check in the view model if we should go to the app token, then we will go to verify app token. Otherwise, we go to verify SMS token. So as you can see, the logic was done in this method, get phone number action. But what if we have more complicated flows, like this one? It gets complicated sometimes. Or even this one, much more complicated. Or even this. This is actually what we had. A lot of activities, a lot of conditional navigations, sort of loop navigations. So how can we make this simpler? Now, of course, we have some complicated logic that we need to implement, but let's try to find a simple way first to understand it and then to maintain it. Okay, so let's start. What we decided to do was to use something called flow behind our flow manager. Again, you can call it anything you want. What this flow does is that it takes the current destination as well as the object, or it could be a view model or a pojo, something that you need to use in order to navigate. And in return, this flow will return the next destination ID that we need to use in order to navigate. So this flow actually works as a map that contains all the navigation logic that we need. As an input, the key will be the current destination ID, and as an answer, it will have a value that is the logic to determine the next action ID that we need to navigate to. So if I want to show you some real code, we can see the register flow that we have. So this register flow defines a data class called action. And this action is actually the map value type that we saw in the previous screen. To create this action, we have this lambda that has as an input the register flow that I actually called the pojo previously. So this is the current form state that we need to use. And as a result, it will return an integer that is the action ID that I need to navigate to. And this is my map. So the map will have as a key the phone number that is the current destination ID, and I map it to the action that is created with this lambda. Okay, so as we can see, all the logic remains inside of this lambda. For example, in this example register flow, what we are saying is, if I am currently at the current destination phone number, check if this user has some invitations. If he does, take him to the invite selection. Otherwise, take him to the pricing screen. So this is a typical example, but you can see that all of the logic that was intriguing was simplified inside of this one place in the flow. And of course, we have this get action for that takes arguments. The first arguments are the destination ID and the form, the project that we have, and it checks if we have this destination ID, it exists, execute, go get the next action, and this will actually return the action ID that we need to navigate to. Otherwise, go to the action next. Of course, the linear flow action next. So as you can see, all of this complicated logic that we had was simplified and centralized in one place. And this is what we actually call the tooling we used for the navigation components. Up next, I'd like to share also with you something I learned about the bottom navigation with navigation components. And I'd like you to visualize with me. I am sure that you all had this before, this experience in some applications before. So imagine with me that you have an application with a bottom navigation view, some tabs at the bottom. And first you have your home fragment. Imagine you tapped on a new tab. You had a list that you scrolled up, and then you went to another tab and you went back. You will realize that when you went back, it actually came back to the first item in the list and not the item that you had already scrolled to some seconds ago. And this is actually a problem in many applications. And this is because we haven't kept a track of the position of the scrolling. We didn't store that and we lost our state. And this is an actual problem we have. So let's look a little bit into the documentation that we have for the navigation UI. So whenever you want to bind your navigation component to your bottom navigation view, you will have to use this method, setup with nav control. Inside this method, you can see that we are linking the listener to the bottom navigation view. And we are calling the method on nav destination selected whenever we select a new tab. Okay? So inside this on nav destination selected method, you can see the different options given. And you can see that when we click on one new tab, we actually have the ability to pop up to the first start destination, which is the start destination, which means the home fragment, the first fragment of our navigation layout. So it is always popping up everything and keeping the start destination. And this is our problem. And I have looked, if we have to skip all of this code, okay, and we have to look at it in a more visual way. Imagine we have this screen with the bottom navigation view. We have 3 tabs, home tab, tab 2, and tab 3. As we have seen in the previous function, tab 2 fragment and tab 3 fragment are linked to the home tab fragment by the pop-up to functionality. So if you have a user and he opens the app, the first thing he can see is the home tab fragment. The home tab fragment is added to the backstack. If he clicks on tab 2, the tab 2 fragment will pop up to home fragment and will actually be added to the backstack. Now we have these both in the backstack. When we tap on tab 3, we can realize that actually the tab 3 pop up to the home tab fragment and tab 2 is dismissed directly. So we only have tab 3 and home tab in the backstack. Now, if we click again on tab 2, of course, we will realize that tab 2 will be dismissed. But the real problem is that this tab 2 fragment is actually a new instance of the tab 2 fragment. And it's not an old instance that we have detached and reattached. No, it's a totally new one. And this is actually the problem. So fragments are destroyed when a tab is opened. And to my surprise, it was actually a bug that was raised on the bug tracker of the navigation component library. It was from 2018. And actually, the Google team has answered that, yes, this is a real problem that we need to tackle. But in order to solve this, we need to support multiple backstacks at the same time. But in order to support this, currently we can't, because this is not supported on the current version of the fragment manager. So it was blocked, but a few months later, they came up and gave us a hack that we can actually use to fix this problem. So I will try to explain this hack for you and how it works. So imagine we have our activity, we have our nav graph that contains our 3 tabs, and I added a 4th fragment, which is behind the tab 3. It's just a detail fragment. And of course, we have our nav host fragment that is added inside the layout. Of course, it's binded to our navigation graph, sorry. And whenever we open the activity, we have our tab 1 that is added to the backstack. We tap on tab 3, and tab 3 is added to the backstack. Tab 1 is behind it. If we open the details fragment, it's added to the backstack. But when we tap on tab 2, actually we will lose both the detail and the tab 3. Why? Because the problem is we don't have multiple backstacks. So in order to solve this, the hack says that we need to use several nav host fragments to create several backstacks. So if I go back to the previous slide, imagine we have different nav host fragments, each one to handle a backstack. Let's see how it goes. Let's see the schema again. So we have our activity. This time we will add a frame layout inside the activity, and it will act as an encore to the bottom navigation view. We have our navigation graph that is now separated into 3 different navigation graphs. 1 for each tab, 1 for each fragment, a series of fragments. And every nav graph will be bound to a new instance of the nav host fragment. And then the frame layout will be able to attach and detach the different nav host fragments that it actually needs to be displayed. And in this way, we have supported the multiple backstacks at the same time. So this is actually a hack, but it's actually working correctly. And a plus to this is that it's provided by the Google team. So if we need to see this in the code, all that we have to do is to list our nav graphs, and then we do the same. We call this function on our bottom navigation view, but this time this function is extra. It's actually an extension function. And this extension function will handle all what I have been describing in the previous slides inside of it. You don't have to worry about how to write it, where to find it. It's actually open source and it's provided by the Google team. You can check it on this link. you can add it inside of your project, and you can maintain it the way we want, the way you want it to be. So finally, as a conclusion, I can tell you that navigation components are clean. Of course, they are future-proof, that they've been part of Jetpack. They've been receiving a lot of updates. It's a Google standard, and that's something I really like when Google really provide a development standard on Android. It's easy to be added into your current project. The tooling is crazy. I haven't been able to show you a lot of tooling, but you saw that all of this complex logic have been reduced into some simple code. Of course, it's not perfect, but I really encourage you to use it if you can. Thank you. Of course, you can get the slides on this link. And if you have any questions, I'll be able to take them now. Okay, so Mubarak, you are asking if you actually need to know all of this. Well, you don't. I didn't need to know all of this if I hadn't used it. So I think you shouldn't complicate yourself and put yourself in this imposter syndrome that we should know everything. We will never know everything. Whenever you need to find a solution, just look it up. Ask people in the community. Everyone is ready to help. And of course, if you need anything, my DMs are open. Yes, so I think software development is all about finding solutions. So whenever you need anything, you can actually learn it yourself, right? Okay, any other questions? And of course, if you can fill the feedback form that you will send, it would be very beneficial for me as well. Yes, Amar is asking, creating Flow Manager was to centralize the navigation logic in one place. Is it better than letting each fragment to explicitly determine the destination? Yes, so we want to use navigation components. So to give you a real example of what we had different forms that needed to be filled. And at some point, you can get to a fragment that needs to go back to some previous fragments. So we had a very big loop inside of the logic, and we needed to make this much more easier to maintain. So whenever I wanted to check the logic again, and go change it, for example, I didn't want to go inside the fragment itself, looking into fragments, but look into one place that contains all of the logic with a meaningful function names that I can actually get to very easily. This was actually the real reason why we created the flow manager. Centralizing the logic, that was it. Of course, I can share again. So this is for the slides and my username. Okay, any more questions? The backstack problem when using view pager. I haven't faced it using view pager, honestly. We can look into this, but I haven't faced it using view pager. Yes, please do. I'd love to get your feedback. Thank you. I hope it was very beneficial for you. And if you need anything else, please, I'm open to any questions. Of course, I will share it again. I can actually copy it and share it with you. This is the link to the slides. Thank you, Mariam. Thank you for having me, and thank you for your support. I'm glad it was beneficial. Okay, so Ala is asking if we use unsafe instance state with fragments. Well, what I know is that you need to override the method unsafe instance state of your activity class as well, because you need to save the activity state before you save the fragment state. Because, you know, the fragment manager in your activity might die with all of your fragments.